Look up at the night sky. What do you see? Stars, planets, galaxies. But what if I told you that everything we can see, everything we've ever observed, makes up only 5% of our universe? The rest? It's invisible. And most of it is something we call dark matter. Our story begins in the 1930s with a Swiss astronomer named Fritz Zwicky. While studying the Coma cluster of galaxies, he noticed something odd. The galaxies were moving much faster than they should have been based on visible matter alone. It was as if some invisible force was holding them together. Zwicky proposed the existence of what he called dunkle materie, dark matter. But his idea was largely ignored for decades. Fast forward to the 1970s. An American astronomer, Vera Rubin, observed the same phenomenon in individual galaxies. The outer regions were rotating much faster than they should be. The galaxy should have been torn apart by its own rotation. But it wasn't. Something invisible was providing the extra gravity needed to hold these cosmic structures together. Rubin's work finally brought dark matter into the scientific mainstream. Today, we believe dark matter makes up about 85% of all matter in the universe and about 27% of its total mass energy content. But what exactly is it? The truth is, we don't know for sure. The leading theory suggests that dark matter is made up of particles we haven't discovered yet. These particles, nicknamed WIMPs or weakly interacting massive particles, don't interact with light or other electromagnetic radiation. That's why we can't see them. But we can see their effects. Dark matter forms the cosmic web, the large-scale structure of the universe. It's the scaffolding upon which galaxies and galaxy clusters form. Without dark matter, the universe as we know it simply wouldn't exist. So how do we find something we can't see? Scientists around the world are employing ingenious methods to detect dark matter. Scientists have built incredibly sensitive detectors deep underground in places like the Gran Sasso National Laboratory in Italy or the Snow Lab in Canada. These are designed to catch the rare occasions when a dark matter particle might bump into a normal atom. At the Large Hadron Collider at CERN, physicists are smashing particles together at nearly the speed of light, hoping to create dark matter particles in the laboratory. Astronomers are scanning the skies, looking for telltale signs of dark matter's gravitational effects. They're mapping the distribution of dark matter across the universe and even searching for potential dark matter annihilations that might produce observable gamma rays. While we haven't directly detected dark matter yet, we're making progress. In 2006, observations of the Bullet Cluster provided the strongest evidence yet for dark matter's existence. More recently, in 2020, the Dark Energy Survey created the largest and most precise maps of the universe's structure, further confirming our dark matter models. Looking ahead, new experiments like the Darwin Project and the Vera C. Rubin Observatory promise to push our search even further. Some scientists are even exploring exotic possibilities like dark matter being composed of primordial black holes or axions, hypothetical particles that could solve multiple cosmic mysteries at once. The hunt for dark matter is one of the greatest scientific adventures of our time. It's a cosmic detective story where the clues are all around us, but the culprit remains elusive. As we continue to chase these cosmic shadows, we're not just learning about dark matter. We're uncovering the fundamental nature of our universe. So the next time you look up at the night sky, remember, there's much more out there than meets the eye. We're all part of a vast, mostly invisible cosmic web on a planet orbiting a star in a galaxy held together by the gravitational embrace of dark matter. Our universe is stranger and more wonderful than we ever imagined. That's why we are reminding you to keep asking, why?